Hello, I'm Robert, voluntary fact check and helping if you're scared, and this is a quick introduction to my non-techie version of the CNEOS Sentry table. I've done a slightly longer video, 25 minutes. I'll try to get this to under 10 minutes. So, first of all, this is what it's saying right now. It says no asteroid or comet warnings. And then if you look at them, the first two say far future, and then below that they all say no hazard. That's what it says right now. Now, if you go and visit the page, I go and look at it. So I click here and visit the page. I have to go through, here we are. Then if you go and visit it, and you just see this page of numbers, and most people that I help, they will just say, oh, I never did maths, don't understand this sort of thing, and click away. But it's really quite simple to understand. The only thing you need to know is this last table. So in order to find out what it means, if you would have to go and you click there. So those blank means far future, 0 means could be that 0 means no hazard. And if you go and look at this page, this translates the numbers into what they mean. 0 means no hazard, 1 means normal, 2, and then they color coded green or yellow. So it's very carefully thought out and well done, except that they don't explain it. That's all. The rest is fine. And then if you click down, if you go down, when you visit the page, you see this thing saying show legend. So you've got to go past the maths barrier of seeing this page and page of numbers. You've got to go to the bottom and click show legend. And then you've got to read this text, which is really quite techy. And then you've got to realize that you need to click on Torino scale. And then once you've done that, you get to that page that I just showed you, and then you understand what the numbers do. And that's just too many clicks away from this page, and most people will never get there. And that includes journalists, clearly, because they run these stories and they just don't have a clue that there's no warning about this object. And then they interview various experts, but they don't bother to, they just don't mention this page. But they could have just gone to this page. This is the gold standard. This was set up by the Congress, and they put vast amounts of money every year to pay these astronomers to search for the objects and to check them and see if there's any hazards from any of them. And this is the table they produce. It's got millions of dollars behind it, but for some reason this page just doesn't have they don't do this really quite simple change that they could make. And then the other thing is that if you click here and you click on search for object, and you can search for the object that scares you. This is back on my non-techie page. And so this is the one that's scaring people right now. You click here and you can see it was removed from the impact list on the 2nd of February. It's year, month. It's the largest time unit first, year, month, day, hours, minutes, seconds. Now this again is just a non-techie interface. If you click through here, then you can do the same search here. I just removed it. Put it in here, search for removed objects, you can find it. And so my page here, that does that in all of that in one go. It searches for the removed objects. It also searches the Sentry table in case it isn't removed, and it will show you any information about it, and then it puts it in non-techie terms that it can't hit Earth in the next century. Makes it very clear to you. And then it gives all these links to other things that you can. So I mean, if you look at that page, removed objects, and then it's a little bit, it's not entirely, totally jumping out to your face that it means it can't hit Earth in the next century, whereas mine does. And then if you click on the JPL small database browser page, then that lets you show that takes you to this page, a whole page of techie numbers, with a couple of useful things here. There's the Earth MOID, that's that is why it's classified as a potentially hazardous object, though it's not hazardous, as we'll see. So you can convert that AU, that's 1 AU is 93 million kilometers, so it's much bigger distance than you think. That is actually, you can put that in kilometers, say put that number in kilometers, and you get 7 million kilometers. So it's really a very far distance. Travelling in a 747, it would take you nearly a year to travel such a distance. Of go around the Earth more than 120 times to travel as far as the distance from Earth's orbit to this object, not Earth, but from Earth's orbit. And then if you go and look at this, the other thing you can do here is you can click on Show Orbit Viewer, and then you wait a little while, and then it'll show the object. And in my longer video, so it first pops up the object name, pops up the planets, and so then this shows it. This shows where it is now. So you can see why. And yes, and the other thing you can do is control the observations. And so it looks. If you go and look here, you can see. Sorry. You can see that it travels quite a long way away from Earth. That's when it's closest. These lines trot down to Earth's orbit. You can see they're quite long lines there, bearing in mind the distance to the Sun is like 3 million kilometres, and it's rather closer to Mars's orbit than to Earth's. Maybe it looks very close to Earth's orbit when you spin this around and look at it. And so, very long term, it's called a potentially hazardous asteroid. This means that it's in orbit that passes close to Earth's orbit, but not that close. It's so far away that it's not going to be much perturbed by Earth. It's probably more perturbed by Mars. It looks like it's got a much higher risk of hitting Mars than Earth over millions of years, just eyeballing this. And then eventually, most of these objects will hit Jupiter, or they will hit the Sun. Eventually, after lots and lots of flybys of other planets. Or they'll fly past Jupiter and be ejected, just like our spacecraft sometimes get a boost from Jupiter when they fly past and then leave the solar system, like Voyager spacecraft and Pioneer. And indeed, yeah. So that's some of the main things from this page. And don't want to go into much more detail in longer videos, so I don't want to. I'm trying to keep this short. So I just wanted to talk about that. Then, if you go down here, you can look at various other options here. You've got what are potentially hazardous objects, and so that explains what I was just explaining. They're not really. Most of these are not hazardous to us. Most can't take centuries to millennia, and they can't change course. And most eventually hit the Sun or Jupiter be ejected from the solar system. A few percent will hit Earth or other planets sometime in the next several tens of millions of years. So that's what potentially hazardous asteroid is, and this is so often misunderstood. But anyway, so the main thing on this page is that if you just bring up the page itself, right at the top, it'll say that as of Wednesday, November the 2nd, the highest, current highest risk, if any, is no hazard, because they ordered with the highest risk first. And then you look at here and you say, far future, no hazard, no hazard, no hazard, all the way down. And then the other thing is that you can use the search for object, which will search this table, and it will search for, and you can click on one of these, for instance, you can click on 1950 DA, and then that will bring up the object already filled in for it. And then, so that tells you that it's a far future possibility, that's only one date it could hit, and the odds against that date are 35,000 to 1 against, so it's expected to miss. This means that as we get closer to that date, we can expect it to be removed from the list. But we've got 7 centuries for our descendants to decide what they want to do about 1950 DA if there is a remote chance of it hitting, and continues to be. And if you click down, I also link to my that's my debunk of it. So if I've got a debunk, I'll link to it. And then you can try the impact effects. You can try an impact in the middle of the Greenland ice sheet, or you can try impact in the middle of the ocean, Atlantic, or the furthest point from land in the middle of the Pacific, and just see what the impact effects would be of this hitting. It's much less than you'd expect from a 1.3 kilometer object. If you click in the middle of Greenland, then it will cause windows to shatter from one coast to the other. But most people would think it would cause far more damage than that at 1.3 kilometers. and impact middle Atlantic would cause quite a big tsunami up to 10 meters high. We definitely don't want these things to hit Earth, but it's not going to end civilization or mean humans extinct. If we were following an object like this, and we had, like even just a few weeks of following it, we'd have many years on that remote chance. And yes, so I explained in my other debunk video that we have discovered, scientists think we have discovered almost all. This is the only one left, 1950 DA, out of 857 near-Earth objects that is still in the risk list. And all the others have no chance. And even for centuries, or it would be in there like 1950 DA. And so probably maybe a handful left, there may be maybe a few dozen, but could be less than that, could be just a handful or so left to discover. They think they discovered nearly all of them. And so it's not at all surprising, it seems pretty clear that we are in a century and a millennium probably without any of these impacts. It's most likely hundreds of thousands to millions of years before we get the next impact of this size. The last one was 700,000 years ago, before modern humans. Anyway, I talk about that in my longer video. And then I've also got my list that your personal impact risk is far less than lightning, or even the very rare, it's called that, did you know, I think, linked to that. Yes, if the Egyptians had asteroid detection telescopes, they would still be waiting for the first asteroid to hit a city, because it's just never happened in all that time. Most likely thousands of years to the first one to do that. And your individual risk is far less than lightning, or even the very rare death from a hailstone, which is it's so rare you hardly hear about it, but 20 deaths from lightning every year in the United States, a death from a giant hailstone every few years, and there's never been a death from a meteorite in the United States in recorded history. There was one lady who got a very bad injury on her thigh, and so bad that she had to be taken to hospital for it, and really quite serious. But that's the only asteroid-related injury in the United States. In the world, 3 reindeer herders were killed in 1908 and a herd of reindeer. And you get a few people die of asteroid every century, but it's an exceedingly rare death, and it's not something to be scared of at all. And it's far less risky than lightning, or even the very rare death from giant hailstones, which does happen from time to time. So if you see giant hailstones putting dents in your car, don't go out and try and save your car, because that's quite dangerous. It's very rare to get hailstones that heavy and that big, and sometimes people are a bit foolish and they go out and they get killed by them, sadly. So anyway, that's it. That's me over, and let's hope this is a somewhat shorter video, and I'll upload it. There's a longer one of 25 minutes that explains and goes into a bit more detail.